All right, so we have our last section for this year. Yay, congratulations, you've made it. This is 11.4 and we are going to divide rational expressions. All right, here are the key concepts for this section. Go ahead and copy them down and replay me when you're ready for the explanation. So the first key concept is just recall when we divide fractions, we are going to multiply by the reciprocal. So for example, if I had 1/3 divided by 4/5, remember that we flip the second one. So here I have 5/4, and we change our division to a multiplication. So we flip and multiply. And this is the exact same process that we're going to have with dividing rational expressions. And you'll see what I mean in just a second. Okay, so here's our first example. We have 5x squared over 7 divided by 10x cubed over 21. And first of all, we have to flip. So we're going to rewrite this as 5x squared over 7. We're going to flip the second one, 21 over 10x cubed, and we're going to multiply. And now, just like we had with fractions, we can actually cross-simplify as well. So we're going to cross-simplify here. 7 and 21 cross-simplify as to 1, and 7 can go into 21 3 times. And we've also got this 5x squared and 10x cubed. Well, 5x squared can go into 10x cubed, let's see, 1 time here, and this left is 2x. And then we just multiply straight across, and we have 3 over 2x. And that's it. All right, I want you guys to try this one. Do it the best you can, and replay me when you're ready for the answer. Okay, so first of all, we were to rewrite this as 15y squared over 4x. And we got to flip and multiply. So we've got 8x cubed over 5y. And this one we can cross simplify. So this goes to a 1 and this goes to a 3y. We're cross simplifying here for a 1 and we simplify this into a 2x squared. Multiplying straight across will give us 6x squared y over 1, but we don't really need to write it over 1 because that's always assumed. So our answer is 6x squared y or 6yx squared. Either way, we can write it both ways. Okay. All right, so those were with monomials. So now we're going to look at polynomials. All right, same process. We've got this division with a couple fractions, so we're going to flip and multiply. So let's just rewrite it first. N plus 1 over n plus 3. Multiply n plus 4 over 2n plus 2. Okay, now with polynomials, before we start cross-simplifying and all that, we want to make sure that we have every little piece simplified. Okay, so do you see anything that's kind of staring at you in the face that needs to be simplified? Well, I see this 2n plus 2. I know that I can factor out a greatest common factor here of 2 as n plus 1. And everything else is in simplest form. So I'm going to rewrite this real quick as n plus 1 over n plus 3 times n plus 4 over 2 times n plus 1. All right, now we're going to cross simplify here. So we're going to n plus 1 here. We've got an n plus 1 here. If you don't like it across this multiplication sign here, we can write this all as 1 like we had from our lesson yesterday. We can rewrite it like this. That's not a problem either. So we can simplify here and here, and we have n plus 4 over 2 times n plus 3. And again, that's the same thing that I got up in this example as well. And then we just distribute this out, so we have n plus 4 over 2n plus 6. And this is our final answer. Okay. So either way, if you want to do your cross simplifying in this form, that's fine. Or if you want to write it all in one big division problem, that's fine as well. Both will give you the same answer. All right, I want you to try this one with polynomials and replay me when you're ready for the answer. So we have b plus 4 over 3b plus 2, flip and multiply, b plus 1 over 3b plus 12. This equals b plus 4 over 3b plus 2 times b plus 1. And we've got to factor out this right here. Well, we got a grace come and factor in there as 3 and b plus 4. And we can cross simplify here, b plus 4 and b plus 4, and we are left with b plus 1 over 3 times 3b plus 2, which is b plus 1 over 9b plus 6. Okay, so hopefully you guys got that one correct. We're going to look at one more type of example with a trinomial involved. And so first of all, before we even start, we're going to flip and multiply this guy. So this is m squared plus 3m plus 2 over 4. Flip, multiply m plus 1 over m plus 2. Okay, so now I look at the problem and I have to find out which one. Do I need to factor? Is there a greatest common factor? Do I need to factor trinomials? And yes, I can factor this guy right here. I don't know what that was. It's supposed to be an arrow. Okay, let's try that again. Well, I'm going to factor this right here. Okay, so m squared plus 3m plus 2 factors out into m plus 2, m plus 1 over 4 times m plus 1 over m plus 2. And here we go canceling out. And this is m plus 1 times m plus 1 over 4. Okay, and now I don't want to give my answer like this in simplified form. What I do want to do is I want to FOIL this back out. And this is going to be m squared plus 2m plus 1 over 4. That's my final answer. All right, here's a problem for you guys. Don't forget that we also are dealing with differences of squares. So if you see a difference of squares in here, make sure you use it. Go ahead and try this as best you can and replay me when you're ready for the answer. So we have p squared minus 4 over 5p times p plus q over p minus 2. Okay, so we've got to factor out this guy right here into p minus 2 over p plus 2 over 5p times p plus q over p minus 2. And we're going to simplify here. And we are left with p plus 2 times p plus q all over, what's left over here, 5p. Okay, and we don't want to leave it like in this form, so we're going to FOIL that out. And when we FOIL that, we get p squared plus pq plus 2p plus 2q all over 5p. And how I got that was I just did this FOIL right here, p squared plus pq plus 2p plus 2q. And that's the lesson. That's it. So I want you guys to try these 5 examples. We've got 1 here, we've got 2, 3, 4, and 5. Good luck.